It was a routine landing at Toronto Pearson Airport, until it wasn't. Just seconds before touchdown, the Delta CRJ-900's cockpit was flooded with a chilling warning. Sink rate! Moments later, the aircraft hit the runway, its landing gear collapsed, and a fire erupted. But what really happened in those final moments? To understand how this routine landing turned into a terrifying crash, we first need to look at the aircraft itself. The CRJ-900 is a part of the well-known Bombardier CRJ Canadair Regional Jet series, a lineup designed to handle short to medium-haul flights with maximum efficiency. Developed as an extended version of the CRJ-700, it offers more seating capacity, better fuel efficiency, and improved aerodynamics, making it a favorite among regional airlines worldwide. But what makes this aircraft so reliable? At the core of the CRJ-900's impressive performance are its two General Electric CF34-8C5 turbofan engines, a powerhouse of efficiency and reliability. These engines are the same ones used in many regional jets, built to deliver both power and fuel economy. Each engine produces up to 14,510 pounds of thrust, providing the aircraft with the capability to take off smoothly, even from shorter runways, an essential feature for regional operations where space can be limited. Positioned at the rear of the fuselage, the engines not only enhance the aircraft's aerodynamics, but also reduce cabin noise, ensuring a quieter and more comfortable experience for passengers. With these high-performance engines, the CRJ-900 can reach speeds of 872 kilometers per hour, Mach 0.83, allowing it to travel long distances in a short amount of time. Despite being a regional jet, it is built to operate at a maximum altitude of 41,000 feet, soaring above turbulent weather conditions and minimizing passenger discomfort. Its ability to climb higher than many other aircraft in its category gives it an edge in fuel efficiency and operational flexibility. Fuel economy is one of the defining strengths of the CRJ-900. Its advanced engine design and aerodynamic improvements significantly reduce fuel consumption, making it an economical choice for airlines that operate frequent short-haul flights. On a full tank, the aircraft can cover distances of up to 2,900 kilometers, 1,553 nautical miles, allowing it to complete routes such as New York to Dallas or London to Istanbul without needing to refuel. This long range makes it a crucial asset for airlines looking to maximize efficiency while minimizing operational costs. But power is not just about speed and range. It plays a crucial role in flight safety as well. The CRJ-900's high-lift wing design ensures better performance during takeoff and landing, especially on shorter runways. Its fly-by-wire control system provides pilots with smoother handling, reducing human error and improving overall stability. The aircraft's impressive thrust-to-weight ratio enables it to gain altitude quickly when needed, making it more adaptable to various flight conditions. However, even with all these capabilities, the aircraft still depends on pilot input and quick decision-making in critical moments. On the day of the Delta CRJ-900 crash, despite the cockpit warning of sink rate, the engine power remained steady at 43% thrust, not enough to counteract the rapid descent. In situations like this, increasing engine power could have been the key to preventing a hard landing. This raises an unsettling question. Was the crew too late to respond, or was something preventing them from applying more thrust? The Bombardier CRJ-900 was designed to blend efficiency with comfort, making it a favorite among regional airlines. With an extended fuselage, it seats 76 to 90 passengers, offering more space while keeping costs low. Unlike older regional jets, the CRJ-900 features a 2-2 seating layout, eliminating the dreaded middle seat and giving every passenger a window or aisle. Storage and cabin space were also improved. Larger overhead bins mean fewer gate-checked bags, speeding up boarding. Bigger windows allow more natural light, making the cabin feel open and less claustrophobic. Enhanced sound insulation ensures a quieter ride, reducing fatigue on longer flights. Pilots also benefit from a spacious cockpit and fly-by-wire controls, making the aircraft easier to handle, even in difficult weather. The aerodynamic wing design helps reduce turbulence, providing a smoother ride for passengers. But while the CRJ-900 is built for reliability, even the best designs have limits. On the day of the Delta CRJ-900 crash, the landing gear, built to absorb impact, collapsed instantly on touchdown. Was it a mechanical failure, or did the plane hit the runway harder than it could handle? The CRJ-900's avionics and safety systems are designed to give pilots complete situational awareness, even in the most challenging flight conditions. At the heart of its cockpit is a fully digital glass flight deck, featuring 4 large LCD screens that provide real-time data on altitude, airspeed, heading, navigation routes, weather conditions, and engine performance. Unlike older analog cockpits, this modern interface allows for quick data processing and clear visualization, significantly reducing pilot workload. Every instrument is integrated into the Rockwell Collins ProLine 4 Avionics suite, a cutting-edge system that enhances flight efficiency and safety by automatically updating flight data and reducing reliance on manual inputs. Another key feature that ensures smooth operation is the fly-by-wire flight control system, which replaces traditional mechanical linkages with electronic signals. This technology provides precise control over the aircraft's movements, ensuring smoother turns, better stability, and quicker responses to pilot inputs. This level of automation makes the CRJ-900 easier to handle, even in turbulent weather or during high-stress situations like rapid descents and emergency landings. However, even with advanced avionics, the real test of an aircraft's safety comes in critical moments, and for the Delta CRJ-900, that moment arrived just seconds before touchdown. Among the most crucial safety systems on the CRJ-900 is the Enhanced Ground Proximity Warning System, EGPWS, a highly sophisticated alert system designed to prevent controlled flight into terrain, CFIT, one of the leading causes of aviation disasters. This system continuously scans altitude, terrain clearance, descent rates, and airspeed, ensuring that the aircraft is on a safe approach path. If the aircraft descends too quickly or is dangerously close to the ground, the EGPWS automatically issues an audible warning, commanding pilots to correct the flight path immediately. These alerts are not subtle. They are designed to cut through cockpit noise with loud, urgent commands to grab the crew's attention instantly. On the day of the crash, just 2.6 seconds before touchdown, the cockpit was flooded with the unmistakable sound. Sink rate! Sink rate! This warning indicated that the CRJ-900 was descending at a dangerously high speed, 1,100 feet per minute, far beyond the safe threshold for landing. At this rate, the aircraft was approaching the runway too steeply, putting extreme stress on the landing gear and structure. Normally, a pilot's immediate reaction should be to increase engine power and pitch the nose up to slow the descent. But in this case, the engines remained at 43% thrust, and no corrective action was taken in time. Aside from EGPWS, the CRJ-900 is equipped with traffic collision avoidance systems, which track nearby aircraft and provide automatic advisories to prevent mid-air collisions. While this system wasn't relevant in this accident, the Instrument Landing System, ILS, should have helped ensure a controlled and precise landing. The ILS assists pilots in low-visibility landings by providing lateral and vertical guidance to keep the aircraft aligned with the runway. However, despite these advanced tools, something went wrong in those final moments. The CRJ-900's landing gear, designed to withstand high-impact landings, collapsed immediately on touchdown. Normally, landing gear is engineered to absorb the impact by compressing under the aircraft's weight, distributing the force safely. However, the sheer force of this touchdown, combined with the right bank angle of 4.7 degrees, may have exceeded the aircraft's structural limits. Despite all of its advanced avionics and safety systems, this crash still happened. The EGPWS gave its warning, but was it too late? Could the pilots have reacted quicker? Did a mechanical issue prevent them from correcting the descent? Or was this simply a case of a routine landing turning into an unavoidable disaster? The CRJ-900's stability and handling are what make it a favorite among pilots for regional operations. Designed to be smooth, responsive, and efficient, this aircraft combines aerodynamic advancements, intelligent flight control systems, and powerful engines to ensure a stable flight in various weather conditions. At its core, the CRJ-900 features an elongated fuselage and an optimized wing design, which enhances both lift and fuel efficiency. Its supercritical wings, designed to minimize drag, provide better performance at high speeds while maintaining fuel economy. This means the aircraft can cruise comfortably at 41,000 feet, navigating above most turbulent weather systems for a smoother passenger experience. One of the biggest improvements in the CRJ-900's handling comes from its fly-by-wire flight control system, which replaces traditional manual controls with electronic signals that translate pilot inputs into smooth, precise movements. This system reduces pilot workload and enhances stability, ensuring that even minor adjustments in flight are executed seamlessly. In difficult weather conditions, such as strong crosswinds or turbulence, the aircraft's automated flight stabilization helps maintain a steady course, making landings and takeoffs much safer. However, in situations where precise handling is required, such as during approach and landing, the CRJ-900 still relies heavily on pilot input. The aircraft is designed to be highly responsive, meaning even small control movements can result in significant adjustments to altitude and trajectory. This is usually an advantage, allowing pilots to make quick corrections, but it also means that a miscalculation in approach speed or descent rate can lead to a harder than expected landing, exactly what happened during the Delta CRJ-900's final moments. As the aircraft descended towards Toronto Pearson International Airport, its sink rate remained dangerously high at 1,100 feet per minute. Normally, pilots would use thrust adjustments and pitch corrections to slow the descent and ensure a soft landing. However, the engines remained at 43% thrust, and the aircraft continued its steep approach. With only 2.6 seconds before impact, the cockpit warning system sounded the urgent alert: "Sink rate! Sink rate!" In an ideal scenario, the pilots could have increased engine power and adjusted the nose angle slightly upward, reducing the descent rate before touchdown. But with the CRJ-900's quick response time and sensitive controls, even the slightest overcorrection could have led to a dangerous bounce or loss of control. Unfortunately, the warning came too late, and the aircraft made contact with the runway at an angle and force that the landing gear simply couldn't withstand. As the wheels buckled and collapsed, the right wing snapped off from the fuselage, spilling a massive amount of jet fuel that ignited within seconds. What should have been a routine landing had turned into a terrifying, fiery disaster. So what went wrong? Was it a failure of pilot response? A miscalculation in handling? Or was the aircraft simply unable to recover from its unstable approach? The answers lie in the investigation, but one thing is clear. Even the most advanced handling systems can't always prevent a crash when time is running out. As the Delta CRJ-900 descended toward Toronto Pearson International Airport, the routine approach took a sudden and deadly turn. Just 2.6 seconds before touchdown, the cockpit was filled with the urgent sound of an EGPWS alert. "Sink rate! Sink rate!" A warning that the aircraft was descending far too fast. The pilots had almost no time to react. With the engine steady at 43% thrust and the descent rate locked at 1,100 feet per minute, the aircraft was on a collision course with the runway. The moment of impact was catastrophic. The landing gear, designed to withstand high-stress touchdowns, buckled instantly, unable to absorb the extreme force. The right wing tore away from the fuselage, exposing fuel lines that ruptured on impact. Within seconds, a massive cloud of jet fuel ignited, sending flames surging around the aircraft as it skidded violently across the tarmac. The passengers and crew, still strapped into their seats, were jolted forward as the aircraft came to a grinding halt amid smoke, fire, and chaos. Inside the cabin, panic erupted. The thick smell of burning fuel filled the air as emergency lights flickered. Oxygen masks had deployed, but it was the quick-thinking flight crew that sprang into action, rushing to get the passengers out before the flames consumed the fuselage. Emergency slides deployed, doors flung open, and terrified passengers stumbled onto the tarmac, escaping into the cold night air. Miraculously, everyone on board survived, but not without injuries. Some passengers suffered burns, broken bones, and concussions, while others were left in shock, struggling to comprehend how a routine landing had turned into a nightmare within seconds. The fire crews arrived swiftly, extinguishing the blaze before it could spread beyond the wreckage. The CRJ-900, a once proud example of modern regional aviation, now lay broken and charred, a stark reminder of how quickly things can go wrong in the skies. In the days that followed, investigators combed through the wreckage, listening to black box recordings, analyzing flight data, and reconstructing the aircraft's final moments. The critical question remains: why didn't the pilots recover from the rapid descent? The EGPWS warning was clear, but was it simply too late to act? Did mechanical failure prevent the aircraft from stabilizing? Or was this a case of human error, where reaction time wasn't fast enough to save the flight? The answers lie in the ongoing investigation, but one thing is certain: aviation is a field where every second counts, and even the most advanced technology can only do so much. The The CRJ-900 was built with cutting-edge safety features, yet when faced with a high-speed descent and a collapsing landing gear, those systems could do little to prevent disaster. This crash will lead to intense scrutiny, new safety protocols, and critical lessons for pilots worldwide, because in the unforgiving world of aviation, there is no room for error. Yet, one haunting question lingers. Could this have been prevented? And could it happen again?